All right, we've been tasked to determine the area under a line. And we're going to use calculus to determine this. First, let's look at the equation of a line. Y is equal to mx plus b is the general equation of that line, where m is the slope of the line, which is just your delta y over delta x. In this case, we're going to have 1/3 as that value. And b is the y-intercept, so we just set x is equal to 0, and we can solve for b. In this case, it's 3. So my equation for this line is y is equal to 1/3 x plus b. And using calculus, we're going to generate these tiny slivers under this line. Okay, and as you note, it's a pretty crude way of doing it. But if you further refine that and get these slivers infinitely small, it becomes a very accurate means of doing that area. Because these slivers, the area is y times dx. Now y is equal to 1/3 x plus 3 times dx. So that's what we'll use to determine the area. But let's first look at a very simple problem. So we're going to simplify it where it has no slope. And so y is equal to b. In this case, y is equal to 5. That's my y-intercept. And it's just simply a rectangle. Really, we're trying to find the area under. And so it would be the area is equal to y dx. In this case, y is 5. So if I did the limits from 0 to 10, I already know that it's 50. But let's go ahead and take this integral. So it's the integral with limits of 10 to 0. And y dx. Okay, so that would be 5 we put in there, because that's the value of y. And then it's equal to 5x after I take the integral. And the limits are from 10 to 0, or 0 to 10, and then I substitute in, and I get 50, which is what we expect for that rectangle. Now, if I were to change the limits from 3 to 7, run through the same calculation, and I get 35 minus 15, which is 20, which is what we would expect. It is 5 units tall, 4 units wide, and thus 20. So now let's look at the original equation. Okay, instead of a straight line, be a little bit more complicated. We're going to take the integral, and I'm going to choose the limits of 0 to 7. Take the integral of 1/3 x plus 3 dx, and it results in, bring the 1/3 out, x squared divided by 2, whatever power you raise it to, divided by, plus 3x, and it's from 7 to 0, and it results in an area under this line of 29.17.